Introduction to Electrochemistry. This is an introductory lesson to the ideas behind electrochemistry, electrolysis, and things like that. There'll be a later video going into more details about things like half equations. But let's start on the intro to electrochemistry. Atoms are made of a positive nucleus surrounded by negative electrons. An ion is what happens when an atom gains or loses electrons. If an atom loses an electron, it ends up becoming positive, because what we've got left is the positive nucleus will have more positive protons in it than negative electrons to balance them out. So more positives than negative gives an overall charge of positive. All metals form positive ions. So does hydrogen. So metals and hydrogen form positive ions. If you have an atom that gains an electron, you get a negative charge. You end up forming a negative ion. All the halogens, chlorine, oxygen, nitrogen, sulfur, non-metals will form negative ions. Not all non-metals will form ions. For example, the noble gases or carbon don't form ions. Some ions are polyatomic. This means that they have more than one atom inside of them. They can be positive or negative. For example, sulfate, carbonate, ammonia are all examples of polyatomic ions. Now, what we can do with an ionic substance is we can split it apart. We split it up using electricity, and when we split an ionic substance, we turn it into its elements. Splitting an ionic substance using electricity is called electrolysis. In order to perform electrolysis, you need an electrolysis cell. It looks like this. It consists of two electrodes, a power supply, and an electrolyte. The electrolyte is the substance that is being split up. It's being electrolyzed. The electrolyte must be an ionic substance, and it must be in a liquid state. So that can either be melted, or that takes a lot of energy, which is expensive, or you can dissolve it in water, which is what's usually done. Then you've got your two electrodes, which have to be made of an inert material. Inert means unreactive, which can conduct electricity. The material that is usually used is graphite. Graphite is unreactive and conducts electricity. Sometimes we will use platinum electrodes, but platinum is very expensive, so that's usually for smaller scale things. The two electrodes carry the electrical current to the electrolyte. The two electrodes have different names. The positively charged electrode is called the anode. The negatively charged electrode is called the cathode. If you're having trouble remembering which is which, don't panic. Panic, because the positive anode, negative is cathode. Don't panic. Get it? So opposites attract. So we got positive ions. So for example, you got sodium, you got hydrogen. They are positive ions. Opposites attract, they are going to be attracted to our negative electrode, the cathode. So if positive ions are attracted to the negative electrode, we name the ions based on which electrode they're attracted to. So positive ions are attracted to the cathode, we give them the name cations. Another way to remember that is cations are positive. A lot of puns in this video. Negative ions, so chloride or oxide, they are attracted to the opposites attract, they're attracted to the positive anode. So we give them the name anions. No pun to remember that one. If you can come up with one, put it in the comments. So they're attracted to the opposites. So the positive is attracted to the negative, and the negative is attracted to the positive. What happens when they get there is they gain or lose electrons in order to become neutral atoms. So if you have a negative ion, when it reaches the anode, it's negative, it's going to be made neutral, so it is going to lose an electron. So negative ions during electrolysis will lose electrons to become neutral. Positive ions, when they reach the cathode, where they are going to become an atom, they are going to gain electrons to become neutral. the number of electrons gained or lost is the same as their charge. 2 minus is going to lose 2. 2 plus is going to gain 2. Sometimes, however, the electrolyte will contain more than 2 ions. The order in which they are discharged depends on the reactivity series. The less reactive of the ions that are present is discharged and turned into an atom first. So for example, if I dissolve sodium chloride in water, I've got 4 ions present. I've got my positive cations, sodium and hydrogen. Hydrogen comes from the water. I've got my negative anions, chloride and hydroxide. Hydroxide comes from the water as well. The 2 positive cations will be attracted to the negative cathode, which will then give them electrons. But which one do we get? Well, if we take a look at the reactivity series, hydrogen is below sodium. Sodium's all the way at the top, hydrogen's about in the middle. So if I'm putting energy in, I'm going to get to the hydrogen first. So the cathode, I have my hydrogen discharged. The least reactive element is discharged. And most metals are more reactive than hydrogen, with the exception of copper, silver, also gold and platinum, but you'll very rarely get gold or platinum ions. So everything except copper or silver will get discharged last. Hydrogen will go first. It will get produced as hydrogen gas. At the anode, it's slightly more complicated. There's a few rules to remember. If you have a halogen ion, which is called a halide, so if you have fluorine, chlorine, bromine, iodine, then you will get the halogen produced. So chloride produces chlorine, bromide produces bromine, etc. It takes away those extra electrons. We end up with Cl2, Br2. If we don't have a halide, remember there's 2 cations and 2 anions. So if we don't have a bromide and we're looking at the anions, the negatively charged ions, then the hydroxide is going to get discharged. And when hydroxide is discharged, it produces 2 things. It produces water and oxygen gas. The only thing you'll see produced though is oxygen gas. So don't say that water gets produced. The water stays in the water, obviously. There will also be, because we started with 4 ions and we've used 2 of them, there will still be 2 ions left in the solution. In the case that I was talking about before, where you have sodium chloride dissolved in water, you've used your hydrogen, you've used your chlorine. What have I got left? I've got sodium hydroxide. The sodium hydroxide is what you form in the solution. You will end up with a sodium hydroxide solution. Okay, so that's the introduction to electrolysis and electrochemistry. There's still a bit more with half equations. Do that another time. Thanks for watching.